Welcome back to my YouTube channel, subscribers. I'm David, the investor data boy, or you might as well call me the A plus ambassador. So I think let me just write that here. A plus ambassador, the universal data boy, ADB. Yeah. So last time we ended here where we had something that was undefined, and we resorted that we're going to use the L'Hopital's rule. So now, how we're going to do this one will be strategic. So since the L'Hopital's rule can only be used for quotients, we're going to try to turn this function into a quotient. So how we're going to do that is we're going to come up with a rule to say maybe the limit as x approaches a of, let's change now, let's say g, a function of x, and h, a function of x. If these, when you evaluate a where there's x, they come back to 0, or anything that would be, maybe this one comes to infinity, this one comes to 0, or the other way around, what we're going to do is we are going to turn this one into a quotient so that we can apply the L'Hopital's rule. Because as I said, the L'Hopital's rule can only be applied for quotients. So what we're going to do here is, we all know to say 2 is equal to 1 over 2. So like you can, it's like you self-reciprocate here, because we know that this one reverts to 1 divided by 1 over 2, and then we're going to say 1 times, or this one goes on top, 2, which comes back to the 2. So you can actually do something like this here. We are going to say the limit as x approaches a, g of x times this one. We are going to do something like this, where we say 1 over h of x. And then when you multiply this one, I'm going to have the limit as x approaches a of g of x 1 over the h of x. So you can put any in the denominator, but it has to make sense. It has to be something that can easily be differentiated when you put it in the denominator. So then when you apply the L'Hopital's rule, you're going to be differentiating this one and this one, because now you actually have a quotient. So I'll give you an example of how we can make something into a quotient. So I'm going to try a different example. Then when we find the concept, when you know the concept, then I'm going to come back to this one. So we realize that this is giving us infinity and 0. So I think at this point you can grab all this and kick in an example. So for example, we have got, this is example 2. We have got x, where we have got f of x, a function of x being equal to x natural log of x. Now this function is being evaluated to the limit, so we're saying the limit as x approaches 0. So now the limit, when you evaluate the limit, we are going to have 0, comma, infinity. Because what happens is natural log of 0 is equal to infinity, then we have 0 when we put it infinity, sorry. Then when you put that one there, we're going to have something like that. So we are going to try now to change this function into a way that it can be evaluated. So now we start. I think I can wrap this. So this is equal to infinity and 0. So what we're going to do is we're going to get the limit as x approaches 0, but now natural log of x, then we're going to say 1 over x. We're going to put this one in the denominator. So now if we put natural log of x down there, we're going to have to differentiate 1 over natural log of x, and then we don't know the derivative of this one, but then we know the derivative of 1 over x. It's actually quite something that's quite very simple. So now we differentiate. So what's the derivative of natural log of x? Well, it's 1 over x. What's the derivative of 1 over x? 1 over x, are going to have x to the power negative 1. Well, when you take this one up there, then when you use the power rule, you're going to have 1 minus 1 over times negative 1 there. So I'm going to have negative 1, negative x to to the power negative 2, which is going to be 1 over x to the power 2. So now there we are going to have something like 1 over x to the power 2. So you still have this limit as x approaches 0. So now the limit as x approaches 0 will be, well, we can try to simplify this, divided by 1 over x squared. So now we're going to have the limit as x approaches 0 of 1 x times x squared over 1, because this one goes to the top. And then now we're going to have the limit as x approaches 0 of x, because 1x will cancel there, 1x will go out, then I'm going to remain with 1x on the top. So now when we evaluate, I think let me start from here. When we evaluate the limit as x approaches 0 of x, well, we're going to just plug in the x there because now we've got something that's defined, and therefore our answer is going to be 0. So now we can try to do that with this question. So for this one, it's actually the same thing as the one we had earlier, except where there is x, there is the whole of this, then this was like the x now. So now, this one, what we're going to do is, we're going to let one be on the bottom, one be on the top. So for this one, any can be, but which one would actually be pragmatic? For me, I think we try this one, so that we can have the natural log of 1 plus 3 over t on the top, and then we have got 1 over t, because it's easier to find the derivative of 1 over t than the derivative of 1 over the whole of this. But then the derivative of this is quite simple when you use the substitution. So now we are going to have, let's start with the derivative of this one using the substitution, where we are let u equal to 1 plus 3 over t, and then we are going to let y equal to natural log of u. So now we are saying dy over dt is going to be equal to dy over du times du over dt. So dy over dt is going to be dy over du, the derivative of y with respect to u is 1 over u. The derivative of u with respect to t, this one is going to be 0. Then this one we're going to have, for this one, then it's going to be t. This t will be 3t to the power negative 1. When you take the t on the top, then you're going to multiply this one by 1, you're going to have negative 3t to the power negative 2. You're going to have negative 3t over t squared. So now this one is going to be negative 3 over t squared. So now when you substitute u there, you're going to have dy over dt being equal to 1 over 1 plus 3 over t times t to the power 2 over, you can change this field, you will multiply it there, it becomes a negative 2. So now this is basically what you have there. So the limit as t approaches infinity of negative 3 over 1 plus 3 t to the power 2 over this. I think we've gone through this. It was like the same one, it was 1 over x. It will be negative 1 over t squared now. So we've differentiated, and then now we have this t that's in the denominator, and then the other t that's also in the denominator. So these t's, they can cancel. Or if you want to really like see what's going on, we're going to have 3 over 1 plus 3 over t to the power 2. Then this one is going to be divided, then switched now, we are going to have times t squared over 1, which is also negative. The negative times the negative are going to multiply. The t and the t are going to cancel. We're going to have the limit as t approaches infinity of negative 3 over 1 plus 3 over t. So now here we can actually, this negative goes negative times negative. So now here we can actually evaluate, because when you have the limit here, it's going to be, there we're going to have a 0, then we're going to have a 1, but then we have a 3 on the top, so it's actually right. So now let's evaluate. We're going to have 3 over 1 plus 3 over infinity. This will be 0, and this will be 1, so I'm going to have 3, 1 plus 3 over 0 over infinity, which is actually 0. Then this is going to be equal to 3 over 1. Then the final answer now is going to be 3. That's how we're coming up with all this. I hope you've understood. And if you have any other further queries or any other questions from the test, zero sheets, or even past papers and you need them to be answered, you can actually send them to my email or my number, which you actually 100978957975, and then we're going to be able to answer it together, because together we can. Peace out.